So in the first example, we saw the central limit theorem illustrated. We saw that if you took repeated samples of the same size, as the sample size increased, so as the value of n increased, we got distributions that were more normal, and then beyond some point, they'll be normal for all sample sizes. So given a random sample of n observations from a population that has mean mu and standard deviation sigma, if we look at that sampling distribution, that histogram of repeated samples of means of samples, then the mean of that distribution of samples, that's mu sub x bar, that's equal to the mean of the population. And the standard deviation of that histogram, that's sigma x bar. So the standard deviation of that distribution of means of samples is the population standard deviation divided by the square root of n. Now notice here as n increases, that the standard deviation of the x bar distribution decreases because you've got n in the denominator. As n gets bigger, the fraction gets smaller. And then lastly, the central limit theorem states that if n is greater than or equal 30, then the sampling distribution of the sample mean, so we're abbreviating that SDSM, will be approximately normal. And the larger your sample size is, the better the normal approximation is going to be. And we also noticed that if n is larger, then our distributions were narrower, which means that standard deviation was smaller. So let's put this central limit theorem to work. So we've got some data here from U.S. Census Bureau, and it states that the mean number of children per family in the U.S. in 2016 was 1.86 with a standard deviation of 0.24. So this is population data, Census Bureau. So what they're telling us there is that mean mu for the population is 1.86, and standard deviation for the population is 0.24, so 0.24 children. And then if a random sample of 50 families here is taken, the mean number of children for this sample belongs to a sampling distribution. It's going to be this sampling distribution of the sample mean for samples of size 50. So we want to know, what is the shape of that sampling distribution? Well, our sample size n here is equal to 50, and that is greater than or equal 30. And so that means that the sampling distribution is approximately normal. So this tells us that our distribution of sample means is approximately normal. So if we take those repeated samples of size 50, we're going to get something that's approximately normal. What is the mean of this sampling distribution? Okay, well, central limit theorem says the mean of the sampling distribution is equal to the mean of the population. So the mean of the x bar values is equal to the mean of the population, which is still 1.86. What's the standard deviation of this distribution? So that's asking us for sigma x bar. And by the central limit theorem, that's sigma over root n. So our population standard deviation was 0.24, and our sample size is 50. So we just need to compute that on the calculator. So 0.24, and we are dividing by square root, dividing by square root 50. So 0.0339. So that's an application of the central limit theorem to a particular sampling distribution.